Welcome back to a new session of the MOOC on Information Security. The topic today is Public Key Infrastructure or PKI. This module describes about the components of PKI, its uses and the types of encryptions used for public key infrastructure. From this module, a learner is expected to achieve the following: understand the concept of public key infrastructure, understand the uses of PKI, familiarize the concept message encryption, learn about the encryption mechanisms used for PKI, learn about digital certificate and certifying authority, and familiarize the components of PKI. A public key infrastructure or PKI. A public key infrastructure is a set of rules, policies, hardware, software and procedures needed to create, manage, distribute, use, store and revoke digital certificates and manage public key encryption. The most distinct feature of public key infrastructure or PKI is that it uses a pair of keys to achieve the underlying security service. The key pair comprises of private key and public key. Since the public keys are in open domain, they are likely to be abused. It is thus necessary to establish and maintain some kind of trusted infrastructure to manage these keys. Key management. Some important aspects of key management are as follows. Cryptographic keys are nothing but special pieces of data. Key management refers to the secure administration of cryptographic keys. Key management deals with entire key lifecycle as depicted in the following figure. There are two specific requirements of key management for public key cryptography: secrecy of private keys. Throughout the key lifecycle, secret keys must remain secret from all parties except those who are owner and are authorized to use them. And the second is assurance of public keys. In public key cryptography, the public keys are in open domain and seen as public pieces of data. By default, there are no assurances of whether a public key is correct, with whom it can be associated, or what it can be used for. Thus, key management of public keys needs to focus much more explicitly on assurance of purpose of public keys. The most crucial requirement of assurance of public key can be achieved through the public key infrastructure or PKI, a key management system for supporting public key cryptography. Components of PKI. The framework of PKI comprises of the following components: public key certificate, commonly referred to as digital certificate; private key tokens; certification authority, registration authority and certificate management system. Digital certificates. Digital certificates are also called X.509 certificates. This is because they are based on the ITU standard X.509. The certification authority or CA stores the public key of a user along with other information about the client in the digital certificate. The information is signed and a digital signature is also included in the certificate. The affirmation for the public key then thus be retrieved by validating the signature using the public key of the certification authority. Classes of a digital certificate. A digital certificate can be divided into four broad categories. These are: class 1. These can be obtained by only providing the email address. Class 2. These need more personal information. Class 3. This first checks the identity of the person making a request. In class 4, they are used by organizations and governments. Process of creating certificate. The creation of a certificate takes place as follows. Private and public keys are created in the first step. Then CA requests identifying attributes of the owner of a private key. Public key and attributes are encoded into a CSR or certificate signing request. key owner signs that CSR to prove the possession of a private key. Then CA signs the certificate after validation. The process of obtaining digital certificate by a person or entity is depicted in the following illustration. As shown in the illustration, the CA accepts the application from a client to certify his public key. The CA, after duly verifying identity of client, issues a digital certificate to that client. Private key tokens. While the public key of a client is stored on the certificate, the associated secret private key can be stored on the key owner's computer. This method is generally not adopted. If an attacker gains access to the computer, he can easily gain access to private key. For this reason, a private key is stored on secure removable storage, token access to which is protected through a password. Different vendors often use different and sometimes proprietary storage formats for storing keys. Certifying authority or CA. As discussed above, the CA issues certificates to a client and assists other users to verify the certificate. The CA takes responsibility for identifying correctly the identity of the client asking for a certificate to be issued and ensures that the information contained within the certificate is correct and digitally signs it. Key functions of CA. The key functions of a CA are as follows. First one is generating key pairs. The CA may generate a key pair independently or jointly with the client. The second is issuing digital certificates. The CA could be thought of as the PKI equivalent of a passport agency. The CA issues a certificate after a client provides the credentials to confirm his identity. The CA then signs the certificate to prevent modification of the details contained in the certificate. Publishing certificates. The CA need to publish certificates so that users can find them. There are two ways of achieving this. One is to publish certificates in the equivalent of an electronic telephone directory. The other is to send your certificate out to those people you think might need it by one means or another. Verifying certificates. The CA makes its public key available in environment to assist verification of his signature on client's digital certificate. Revocation of certificates. At times, CA revokes the certificate issued due to some reason such as compromise of private key by user or loss of trust in the client. After revocation, CA maintains the list of all revoked certificates that is available to the environment. Registration Authority or RA. CA may use a third-party registration authority or RA to perform the necessary checks on the person or company requesting the certificate to confirm their identity. The RA may appear to the client as a CA, but they do not actually sign the certificate that is issued. Certificate Management System or CMS. It is the management system through which certificates are published, temporarily or permanently suspended, renewed or revoked. Certificate management system do not normally delete certificates because it may be necessary to prove their status at a point in time, perhaps for legal reasons. A CA along with associated RA runs certificate management system to be able to track their responsibilities and liabilities. Hierarchy of CA. With vast networks and requirements of global communications, it is practically not feasible to have only one trusted CA from whom all users obtain their certificates. Secondly, availability of only one CA may lead to difficulties if CA is compromised. In such cases, the hierarchical certification model is of interest since it allows public key certificates to be used in environments where two communicating parties do not have trust relationship with the same CA. The root CA is at the top of the CA hierarchy and the root CA certificate is a self-signed certificate. The CAs which are directly subordinate to the root CA, for example CA1 and CA2, have CA certificates that are signed by the root CA. The CAs under the subordinate CAs in the hierarchy, for example CA5 and CA6, have their CA certificates signed by the higher level subordinate CAs. Certificate authority or CA hierarchies are reflected in certificate chains. A certificate chain traces a path of certificates from a branch in the hierarchy to the root of the hierarchy. The following illustration shows a CA hierarchy with a certification chain leading from an entity certificate through two subordinate CA certificates CA6 and CA3 to the CA certificate for the root CA. The following procedure verifies a certificate chain beginning with the certificate that is presented for authentication. A client whose authenticity is being verified supplies his certificates, generally along with the chain of certificates up to root CA. Verifier takes the certificate and validates by using public key of issuer. The issuer's public key is found in the issuer's certificate, which is in the chain next to client's certificate. Now, if the higher CA who has signed the issuer's certificate is trusted by the verifier, verification is successful and stops here. Else, the issuer's certificate is verified in a similar manner as done for client in above steps. This process continues till either trusted CA is found in between or else it continues till root CA. Challenges that a PKI solves. PKI owes its popularity to the various problems it solves. Some use cases of PKI are securing web browsers and communicating networks by SSL TLS certifications, maintaining access rights over intranets and VPNs, data encryption, digitally signed software, Wi-Fi access without passwords. Other than these, one of the most important use case of PKI is based around IoT, that is Internet of Things. Here are two industries that are using PKI for IoT devices. The first one is auto manufacturers. Cars these days have features like GPS, call for services, assistance, etc. These require communication paths where a lot of data is passed. Making these connections secure is very important to avoid malicious parties hacking into the cars. This is where PKI comes in. Another field is medical device manufacturers. Devices like surgical robots require high security. Also, FDA mandates that any next generation medical device must be updatable so that bugs can be removed and security issues can be dealt with. PKI is used to issue certificates to such devices. Disadvantages of PKI. Speed. Since PKI uses super complex algorithms to create a secure key pair, so it eventually slows down the process and data transfer. Private key compromise. Even though PKI can't be hacked very easily, but a private key can be hacked by a professional hacker since PKI uses public and private key to encrypt and decrypt data. So, with user's private key in hand and public key which is easily available, the information can be decrypted easily. Uses and importance of PKI. PKI is crucial for high security situations. With digital signing along with public and private cryptographic keys, PKI provides trust that can be used to secure a variety of applications. If the certificate was issued by a source that server knows and trusts, then the server will accept the certificate as proof of identity. It's like the TSA officer verifying the validity of your driver's license or passport authorized by the government. PKI security is used in many different ways. The main ways that PKI security can be used are securing emails, securing web communications such as retail transactions, digitally signing software, digitally signing applications, encrypting files, decrypting files, and smart card authentication. Types of encryption PKI uses. PKI merge the use of both asymmetric and symmetric encryption. Both symmetric and asymmetric encryption have their own strength and best use case scenarios, which is what make the combination of both so powerful in public key infrastructure. Symmetrical encryption. Symmetrical encryption protects the single private key that is generated upon the initial exchange between parties, the digital handshake if you will. This secret key must be passed from one party to another in order for all parties involved to encrypt and decrypt the information that was exchanged. This secret key can be in the form of a password, or it can be a series of random numbers or letters generated by a random number generator or RNG. Asymmetric encryption. Asymmetric encryption or public key cryptography uses two separate keys for encryption and decryption. One of them is known as public key and the other is a private key. The public key can be generated from the private key, but the private key cannot be generated from the public key. The private key and vice versa can only decrypt encryption done by the public key. Together, these keys are called public and private key pair. Asymmetric encryption is fairly new to the game and you may know it better as public key cryptography. The public key encrypts and the private key decrypts. It allows you to create a public key for the party who is reporting to you, so that they may encrypt their incoming information, after which you will be able to decrypt the information with a private key. In SSL certificates used for encrypted communication between a client and a server, a public key is attached to the certificate, which will initiate a secure communication between two parties. Asymmetric encryption is a newer type and slower compared to symmetric encryption. Asymmetric encryption is used to exchange a secret key, which is done during the initial handshake between the two parties. The secret key exchange is used to establish symmetric encryption for further communication. Symmetric encryption is faster than symmetric one, so the combination of them both provides robust end-to-end security. Symmetric encryption, unlike asymmetric encryption, uses only one key for both encryption and decryption. It is faster than asymmetric encryption, but if the key is compromised, anyone can decrypt the contents encrypted. Therefore, asymmetric encryption is used to ensure the secret key is not compromised and the connection remains secure. The key problem in conventional encryption. Let's first consider a simple scenario we are already familiar with. Let's say there is a spy named Alice who wants to send a confidential piece of information to Bob, her senior officer. She can't send this information in plain text, as enemies could easily intercept and read or tamper with it. That's why she must send this information in an unreadable form that Bob will be able to derive. But their enemies won't. In other words, Alice will need to encrypt the information, but here comes a problem. If Alice locks or encrypts the message using a key, some logic, then to decrypt it, Bob must have the key with him. To give the key to Bob, there is no option other than meeting with him face to face, which is totally impractical, to say the least, or to send it via courier and risk it being intercepted. Such an encryption method is problematic not only in the physical world but also in the virtual world. Every time two computers want to communicate securely, they would have to agree on a single encryption key every single interaction. This is a mathematical process and takes time. And if there is a server for example a bank, that communicates with multiple users, then the server will have to perform a computational process for each client transaction, and that would slow it down even further. All of these things involve a variety of complex processes and agreements that must be handled at micro speed. That's where PKI comes in. In addition to conventional encryption, also known as symmetric encryption, in which the same key is used for encryption and decryption, PKI also involves the use of a key pair, a public key and a private key, in a process that is intuitively known as public key encryption. One of these keys encrypts information and the other decrypts. Both these keys are distinct, but they are mathematically related to each other. It means that the information encrypted with one key can be decrypted only using the key associated with it. The public key, as the name implies, is available publicly. The private key, on the other hand, is kept private. So, if Alice and Bob are using public key infrastructure instead of the symmetric encryption method, Alice could encrypt the secret message using Bob's public key that she has. Bob, with his private key, is then the only person who can decrypt the message. This way, they could communicate securely without letting their enemies read or tamper with it. Not only that, but Bob can be sure of that the message came from Alice and not from someone else. A public key infrastructure, or PKI, is a set of roles, policies, hardware, software and procedures needed to create, manage, distribute, use, store and revoke digital certificates and manage public key encryption. The most distinct feature of public key infrastructure, or PKI, is that it uses a pair of keys to achieve the underlying security service. The key pair comprises of private key and public key. PKI merges the use of both asymmetric and symmetric encryption. Both symmetric and asymmetric encryption have their own strength and best use case scenarios, which is what made the combination of both so powerful in public key infrastructure. Hope you enjoyed this session. See you next time. Until then, bye.